All right. Okay, so if we can join back into DSC7U, that would be fantastic. All right. Thinking market failure, thinking about the different cost structures, the different revenue structures, and how to portray them graphically. Right. So DSC7U, if we can jump in there, that would be awesome. Last we left off, we talked about what does it mean for an imperfect competitor to have a downward sloping demand curve. One of the key things that we remember all the way back to when we learned about demand was that a downwardly sloping demand curve told us that the only way we could see an increase in quantity would be if the price was to decrease, because it was following the law of demand. So an increase in quantity would be possible if the price was falling. So for those imperfect competitors, yes, that includes the monopolist as well, if they are wanting to increase quantities, they might actually need to decrease their prices. Right. What happens when marginal revenue goes below zero? Well, quite straightforward. Remember that your marginal revenue is the change in your total revenue. So if marginal revenue is zero or below, what does that say, mathematicians, about total revenue? Yeah. Marginal revenue equals total revenue, revenue 2 minus total revenue 1. So if marginal revenue is negative, for example, because it's gone below down here, then what we're saying is that this calculation is going to have to be decreasing, isn't it? Yep. What about your average revenue? What does average revenue equal? Yes, which also equals average revenue equals total revenue divided by quantity. So average revenue equals price. Is it possible to get down there? Is it possible for average revenue to be below zero? Why not? Right? It does become quite complicated at the extremes. Yes, well done. Okay. We talked the other day about how marginal revenue was going to fall or decrease at twice the rate of your average revenue. The suggestion is that why it is doing that is because you've actually got to lower your prices to sell more quantities. So although you are seeing an increase in quantity, you are having a decrease in price to gain that. Where will the imperfectly competitive firm marginal revenue cut the quantity axis, and how do we know that? You don't seem to be in the near pod at all, Mel. No? Yeah, there's a lot of you. I was using an old one. Okay. Well, I can get rid of the extra U's if you want, Adam. If I accidentally lock you out, please don't panic. I'm assuming that the newest one is you. So 0 and 12. Zara should already be in there. Kenneth is already in there. We're missing a Faisal. Alright. Good morning. Okay. Yes, that's right. Yep. And how do you know that? What's actually going on there? Remember, if MR equals 0, what does that say about total revenue? Right, remember, total revenue, price times quantity. Marginal revenue is the change in total revenues. So if marginal revenue equals 0, what does that tell us about the change in total revenues? Wait for the mathematicians to start making them. Okay. Alright, marginal revenue. TR2 minus TR1. So if MR equals 0, what does this for total revenue? Yes, thank you. Well done. That means at that quantity, there is no change in total revenue. None. Can't be. Because marginal revenue is 0. Yeah? So if you like, that's a turning point between the positive numbers and the negative numbers. So the turning point between when total revenue is increasing and then it starts to decrease. Yeah? So, right. MR equals 0. Yeah, mathematicians, am I right? Ickmal says I'm right, so must be right. So here, total revenue is positive or increasing. Here, total revenue is negative, right? Negative or decreasing. Right, that. Gone. Low in your mind. Point. Yes, good. Right. So, here's what the theory tells us. All imperfect competitors are going to face a downwardly sloping demand curve. All of them. Now, our spectrum had perfect competition at the extreme end. Right? So there's going to be a whole bunch of imperfect competitors. In fact, pretty much... Oh, hello.
Hi. Hello. I'm so sorry I forgot to pop in.
Good to see you. You alright?
Yeah, I had introduced the student council.
Yeah?
Yeah, I thought one of them was going to help you, but fine. I did. I thought you did. Oh, sorry. You had to introduce you. Thank you.
Ah. Well, it's alright. I mean, we missed you. Right? Tira was almost inconsolable. There were tears.
Yeah, I know.
But at the very least, we had Joshua, so, Tira was mollified because there was still Joshua's. So. Right, the Romeo of your year group, Joshua. Right. Consumers are going to be less responsive. Check this one out. Less responsive to higher prices because there's going to be less firms in the marketplace. Now that less responsive phrase has to do with our concept of elasticity. So what we're actually suggesting here is that the demand curve is actually going to have different levels of elasticity depending where you are on the curve. So with higher prices, you're going to have a less elastic or more inelastic demand curve, and with lower prices, you're going to have a more elastic demand curve. That's going to be significant. Right, so if we draw it up, here's our demand curve, equals average revenue. So that's your inelastic portion. That's your elastic portion. What am I missing? There are only three basic descriptors for elasticity. One was that it was inelastic, looking like the letter I. One was that it was elastic, looking like the letter E. But what's happening here in the middle? Trying to see if that's exactly in the middle. Exactly in the middle. Something's happening. Yeah. No. Yeah. level where fair, but yes, thank you. Good. Joel will be proud. Yeah, it's going to be unitary. That one quantity here, we are going to find is going to play a really significant part in what unfolds next. Okay? Right. So, because we're imperfectly competitors, we are an imperfectly competitive firm, your average revenue and your marginal revenue now do not equal each other. Right? Reason why, as we said, was because you had to reduce your prices in order to increase the quantities that are sold. And there's a wee explanation from Econ plus Dale, which is very useful, and I would recommend reviewing that and another one. Right, now, where did the firm maximise its profits again? What was the quantity? Good. MR equal to MC. Right, so the profit maximising quantity was where MR equaled MC. How did we calculate profits again? PR minus MC. Now, you guys are all mathematicians. Yes. Right. I got told by one of you that their favourite subject is maths. I'll let you guess which one. TR here is equal to price times quantity. TC here is going to be the costs times the quantity. Now again, you can play with these, right, and figure out what's actually going to happen. Right? If you are mathematically so inclined, you've got two quantities in here. All right? And this then is your price and your average costs. Yep. Yes. So P minus AC is going to be another important equation for us to think about. In fact, the whole relationship between P and AC is going to be really important for when we're figuring out profits. But right. Total revenue, total costs, total profits. There's that turning point that we saw where your marginal revenue is equal to 0. So the maximum distance between these 2 points here is going to equal this quantity here as the most or maximum level of profit that you can earn. If you're earning less than that, so down in here you've got total revenue being greater than total cost. If you're up in here, you've got total revenue still being greater than total cost, but you're on a declining total revenue, and eventually total cost is greater than total revenue. So the biggest distance between them is right there. Now again, mathematically, there are turning points involved, there can be differentiation, and all of those sorts of algebraic things can happen within there. Alright? That doesn't happen in your syllabus, but when you get to university, depending where you go with your economics at university, you can expect the maths to gradually crank up into that sort of a level. Right. So, now it is your turn to have a go at the giraffes. How will a firm maximise its profits?
I found it quite traumatic. I didn't understand it. I didn't understand it. It's surreal. See, the one we did mix together with cuts out some carbon and fish and all those. But when I was the phrase merged together kind of appealed to me. And so I wrote a very story called Emergency in This Way. Space aliens with flying I thought that I still I did perform and a few music classes, so that was mainly music. Well, most of the work I did on my father. The last one I did was a real My father would tell me that if I can. I don't like singing constantly. I haven't since I was little. My father would tell me. And I was in the little band. Well, you know, they have every band players. Band.
All right, good work, team. All right. Gosh, that's very good. Absolutely right. Well done. Good. I drop it onto the axis because it's that quantity that's quite important. Yep, same here, I drop it down to the axis. Which, well, it's done, more or less. And Sarfan has got spaghetti. Good man. And Adam, we're still waiting on Adam's right. Zara's. Here it is. Right, Adams, yes, that looks alright. Yeah.
Okay.
Yeah, okay. Wait on Tira. Yeah, so several yeah, I don't So every now and then he and I talk about music. Right, let's take a closer look at the margin. Right, now in front of you there's a table on which you've got your computer.
Oh, what? Oh.
There's also this. Now in the past, a long time ago in a galaxy far, far away, you used to have to actually complete these tables in an exam. Not expecting you necessarily to have to do that now, although paper 2 calculation based. So yeah, you could get a smaller sort of cut down sort of size version of it and then have to complete it. So if we have a look and go through very quickly, how do we work out total revenue again? Total revenue equals price times quantity, marginal revenue, change in TR. So if we go here, there's your price, there's your quantity. So the first one, total revenue, you're earning nothing. Yeah. 50 times 1, 50. Yeah. Then let's work out the change from here to here. No, so from here to here, 50. Yeah, with me so far? Right. Now the price hasn't changed here, so what assumption do we make? If the price hasn't changed, what assumption would we make? Yeah. Yes. And yes, I used to lose marks because the examiner couldn't read my writing, or the figures would look like other numbers. Yes.
How do you write 4?
How do I write 4? Yeah, we were asking for that. Yeah. Also possible to do that. Yeah. But it's always the question of whether it's this one or whether it's B4. But then it depends on whether they're playing the B's are playing golf or not. I'll be here all week, try the veal. Right. I didn't ever get around to your name, Adam, did I? I keep thinking to say it, but I never did it. Ha-Adama. That's actually how your name used to be spelt. right? And then because that's what it was. That was the word, right? Man of red clay. Man of the red, either man of red clay or man of the red dirt. Right? And that's what the word was. Yeah. Then, because when that was handwritten, right? But it was handwritten with just the consonants, so just H, D, M, H. Yeah. Right. So it was up to you to put the vowel sounds in when you read it. Right. So O's, A's, I's, E's. Could be a number of names depending on how you came out with it, yeah? Right? But when it got to the mechanical typeset, or the printing, then each letter costs money. Right? So then that was when they made the call with a lot of words, what letters were actually in the words and what ones weren't. Yeah? So very quickly it became much less letters. Well, I used to pronounce it Ha-Adama. But well, it's because it's the first name. Yeah? So in any case. Right. So therefore no. 100, 1,500, 150, 200, 250, 300. Yes? Done that quick? Marginal revenues, change in. Which makes sense, doesn't it? Because this is perfectly competitive, so your price should equal your marginal revenue. If I was to put average revenue here, that would be total revenue divided by the quantity. So it would end up being that as well. What about that one? You've got about 2 minutes. Have a go. Here's pieces of paper, you've got pens, you can have a go, or you can do it on your computer. You. Is there a possibility? Yes. Is there a likelihood? I would hope not. Because I hope that's going to roll out happening in January. Much less like a hundred. But yeah, that's it. All right, here's your mathematical question. Your mathematical question. Why is that one blank?
Because that's what fixed cost. That's the fixed cost.
Here, it's marginal cost.
I mean, the 100, the total cost is 100, right?
Yes.
And now we fix it, so it can't go below 100 because it's a fixed cost.
Which means,
That's the line price, right?
yeah. So it means that your marginal costs are not going to begin at zero or any of those sorts of things. They're actually going to be a positive number, right? So they're not going to start near zero. So why isn't that zero?
Because it's fixed cost.
Remember, your marginal cost is the change in total costs.
Zero.
So
You're not changing from anything, so there's no change.
yeah. So the most accurate way in a table form to represent that isn't obviously with a zero, it's with a horizontal line like that. That's the most accurate way of representing it. And what I used to have to do in New Zealand was to say to them it has to be a horizontal line. It can't be a vertical one. Yeah, because otherwise the examiner would read it as the number 1. Because they're New Zealanders. Right? We do silly things like that. Even a diagonal. No. Don't do it. I'd rather you left it blank. So what did we notice about this model? Is this perfectly competitive? No. How do you know?
Price changes as
The price changes as output changes, and in fact the price decreases as you increase the quantity. Good. What about your average fixed costs? What about your average variable costs? And your average total costs? So, firstly, how do you work out average fixed costs? Good. So your average of your fixed costs is going to equal the total of your fixed costs divided by your quantity. How would you work out the average of your variable costs? Yes. Your average variable cost is going to be the total variable cost divided by the quantity. Your average of total costs, or average total costs, in other words, average cost, is equal to either the total fixed cost divided by quantity plus total variable cost divided by quantity, or average total cost is equal to average fixed cost plus average variable cost. And again, mathematically, you can play with them. All right? Now, the examiner might try to test you a little bit on your maths. And that's not about the economics, that's just the maths of it. So if you're given a part of the equation and have to rearrange it, yeah, that's just a math skill that you will need to know. Right? So if you're given part of the equation here, so you've been given average total cost and average variable cost, and you're asked to work out average fixed cost. Yeah? Or some other combination. That is just a math skill. It's a little bit of an understanding about how the costs all work, but it is just a math skill. But the questions weren't necessarily about the equations for them. The question was about what they look like. So if we take the average of your fixed costs, your total fixed costs, they're going to be one number, yeah? So what is your average of that number going to look like?
Same number.
Yeah, well your fixed costs, they don't change. But do the average numbers change, the average of them?
Yeah.
Yes, they do. So if you're going to draw it, what will it look like? It'll have to start somewhere. So it might be here, and then it will just go down.
It's not a straight line, right?
No, it's whatever that word is you use in maths. Yeah, but it's going down. I don't know. And it never quite touches the axis there. Right? So it looks like that. Now, the average variable cost and the average total cost are different because your variable costs increase as your quantity increases. Right? And then your total cost, your average of your total costs are added together. So you're either looking at total costs and dividing it by quantity, or you're looking at adding your average of your fixed and your average of your variable costs and trying to work it out. So, if we were to draw it, what do we think? Well, let's think about the average variable cost. What will it look like? It's going to start somewhere here. Yes, it will. Well done. It's actually going to go down initially and then come up. Alright? It is the average of your variable costs. Quantity costs. A, B, C. Alright? Then, if you were to add this cost curve to the average of your fixed cost curves, what is that going to look like? So in other words, what does the average total cost curve look like? Yes, it will. Right? Because it has parts of your fixed costs, but also parts of your variable costs. So it will end up looking average total cost, but most people leave out the total, just call it average cost. It's going to look like that. What does it look like? How would you describe the curve? Parabola. That sounded very Australian. Parabola. Not nice. An upside down rainbow. Well, if that isn't a metaphor for 2021, okay, let's go a little bit more, I was going to say metaphorical, maybe. Is there a letter of the alphabet that it looks like? What does it look like? What does it look like?
It's like a C, but flips rotated
A C that has been rotated anti-clockwise. Do you see what I'm working with?
Imagine if you get R and you bend it over.
An R that you've bent. Okay.
How about half of an S turned around?
Yeah. Half of an S turned around.
Wait, a U but flip 360 degrees.
Alright. I was going for a particular joke that I use every single time, and it's not going to work. All right? Yes. Getting there. Hold your horses. All right? The joke that I usually use with this particular curve is to ask you what it looks like. And then, right? And then I say, what letter of the alphabet does it look like? And that's when people call out U. At which point I say, no, it doesn't look like me. What letter?
That was a good one. That was a good one. You said
Right.
360 degrees, I think you had to turn around. Yeah, so imagine you make 360.
Okay, now, us economists are simple-minded folk,
360.
and the way we explain an average cost curve is very simply to describe it as a U-shaped curve. Not a U-shaped curve, a letter U-shaped curve. Yeah? Which you could say that, right? I've had students who say it resembles a bowl. Yeah, okay. Maybe, right? Something along those sort of lines. But again, what we're going to find is that this point here, this quantity here, is going to be very important. Right? What we're seeing here, this is again another turning point. So up until here, this is your costs. Right? So for all quantities up to here, you've actually got decreasing average costs. See that? Then, for all quantities above here, you've actually got increasing average cost.
So, isn't that the place where the difference between PR and TC is the greatest?
You're on the right path. You're absolutely on the right path. Right? So this quantity is what we call a technical optimum. Yeah? What we are seeing here, if we were to extend the line all the way up, that, again, on this side of the quantity here, this is declining average costs over output. And the term we use in economics for that, which Zafan knows, is economies of scale. Okay? This side, we've got increasing average costs per output. So we've on this side got economies of scale. Right? But it gets even more scary than that, because we can actually describe these on the relation to the returns that you get. Because if you've got declining average cost, you've actually got what's called increasing returns. And if you've got increasing average costs, you've actually got decreasing returns. Right? So again, that's another reason why this point is considered to be the optimum. So more or less, that point is going to be the best you can possibly produce at. What quantity do you think we should be producing at? This one. Right?
That's only assuming that revenue is constant, right?
Yeah. Oh, it doesn't matter about revenue. We're just talking about costs. When we're looking at the costs, if we produce any quantity less than that, we could always do better by producing more in terms of economies of scale and returns to that factor. Any quantity above that, we're actually losing on the basis of increasing costs. So we'd actually want to do less quantities until we hit that technical optimum.
Why is it called technical optimum?
It's a very good question. I don't know. Right? I've always known it as the technical optimum, which I found quite funny because the code was TO. Yep. So in university I would draw these up, and then because that's too many words for me to remember, I just do codes. I would codify it. So that would be TO. Here I've got EOS. Here I've got DEOS, the diseconomies of scale. Here I've got increasing returns to scale. Here I've got decreasing returns to scale. Yep. And that way I would remember it, and I'd have different colours and all those sorts of things. And it's very visual, so be remembered quite quickly. Alright, so what did the average fixed cost curve look like? Sure. The average fixed cost curve. Bonus points if you can tell me why. No, it doesn't, Iqbal. Bonus points if you can tell me why. Oh, goodness me. I have no idea what that means.
It like goes down, but then it's like moves like that.
Okay, then I'm going to say possibly. Yeah, Zara, you're wrong. No problem. Yes, you're right there, Adam, assuming that's what that means. Yep, okay. That's better. Yep. Anybody like to hazard a guess as to why? Why does it look like that? Yes, why? What are you actually doing? Yes.
But then the more quantity that you have, like the percentage per quantity of that fixed cost is lower.
Yeah, okay. Well overthought, but yes. Alright, in essence what you're doing as you increase your output is you are spreading a fixed cost over greater numbers. Yeah, that's it. Yep, but well done. Giraphically, look at that. Now, in the old days we used to ask you to explain the relationship between curves. Okay? To which, people are going to say, oh, are they brother and sister? All right?
The last time, no.
All right, that's your total cost curve there. Average total cost right there, or average cost. Then you've got average variable cost and average fixed cost. So if you add this curve to this curve, you're going to end up with this curve. That's the relationship. Yeah, this curve is the sum of these two curves. Now, all right, how about this? Shall I ask you this or not? Yeah, we'll come to this later, I think. I was going to ask you another question, but I think we'll come to that later. Right. Now, there is another little math magic thing with regards to the curves, but I'm going to say we're going to cover it a little bit later, because I think that the way they're represented there might not give you the idea that I'm wanting you to see. Okay, so we'll see it, I think, later. Right. Yeah, getting close. Here we go. What is the difference between an ATC and an ABC curve? The fixed costs. Well done. So again, if you're asked to do the calculations, you can actually calculate these ideas from the graph as well. Yeah? So it might be you get it as a table, could be that you get it just as like words in a paragraph, or it could be that they give you a graph and ask you to actually do the calculations. It's possible. And in the past, we definitely used to get you to do that. Right, the totals. Right, marginal cost, that was the only one that we didn't include. What is the formula for marginal cost? Total cost. So what's it going to look like? Yes, it will. Right? Quite literally, the total cost curve is going to, the marginal cost curve is going to look like the total cost curve, but it is, the average total cost curve, but it is going to have a much longer tail. So in New Zealand, I used to explain it in two ways. It either looks like the letter U with a long tail, or because the students understood this a little bit better, it looks a bit like the Nike swoosh, or Nike tick, depending on... Oh, I think it. Oh, that's a good one. That might work better for you, right? So think of it that way. Okay. So, because it is the change in the total costs, it is then going to relate to the other curves as well, because that's a fixed cost that doesn't change. But the variable costs will change. So it's going to initially start up, then it's going to decline as your fixed costs are spread over a greater quantity, so like the average fixed cost, and then because your variable cost is increasing, it then increases. All right. Ta-da! Yeah, costs. For that. Now, normally, this took me a little while to find, by the way. Normally, we don't show the average fixed cost curve, okay? Because there's very little point in showing it, because the analysis actually mainly falls with these three. Okay? Now, right, here's a question for you. Where does the marginal cost curve intersect with the other two cost curves? The average total cost and average variable cost. Where does it intersect? Yes, he did, but then he backed away from his answer because he didn't believe in himself. Yes, you are absolutely right, Zarfan. Yes, the technical optimum. The lowest point here, there's the TO, and that one, which is also the lowest point for the average variable cost. And the rule is it has to. It has to intersect those two curves at their lowest point. So, here's a bit of an issue for us. If you're in an exam and you are being asked to illustrate this particular market structure, which is not impossible, and you draw it like this, no problems. If you instead draw it and because you're getting a bit hyped up and got to draw it right, and you draw it so that it doesn't intersect at the lowest point, visually it's going to be very easy to see. And the examiner is going to immediately say it's wrong, because it has to connect with these 2 points. Alright? That one being the technical optimum, which is, as said, really significant. Now this one here is an average variable cost. That has a significance. What do we think the significance of that particular minimum point is? That's the lowest point on an average variable cost curve. What do you think the significance might be of that? I've already talked to you about it before. We've mentioned this point before. Not there. There you are. It's the lowest point on the variable cost. The hint is variable costs. What are your variable costs? Name some variable costs for me. Wages. That's quite significant. So if that's the lowest point on your average variable cost curve, what does that tell you? One of those costs is wages. No, not quite. Why wouldn't you produce down here? Just randomly shooting at them for some particular reason. That's the lowest of your variable costs. Right? One of those variable costs is wages, which is what the workers earn. Yeah? So that's the least of your variable costs. That's the smallest amount of costs that you can pay before your business has to stop. No, the shutdown point. Why are we shutting down before then? So that's your shutdown point. Because that's your average variable cost. That's your wages. What happens if you don't pay your wages? Do your workers work out of love? Do they? They might. So committed to the team that we're prepared to work for no money. Is that how it works? Hopefully. Yeah, welcome to the real world. Yeah? Typically, yes, they won't. Is the answer to the question. Workers want wages because they use their wages to pay their bills. And at least here, you are contributing to that. You may not be paying all of the workers' wages or all of your variable costs, but you are at the very least contributing to them. You have to pay your fixed costs. That's a given. Right? So there's contributions to fixed costs going on. Yeah? But if you're not contributing to your workers and their wages or the raw material costs or whatever it is, then you don't pay the electricity bill. They turn it off. How much are you going to be able to produce? Yeah? So that indeed is your shutdown point. Now, if that's your shutdown point, what do you think this one's going to end up being? It's going to end up being break-even. Yes, it is. Right, now we haven't got to that point yet, but that is indeed what it's going to be. Now, here we go. Let's see how far I can push you with this. If this quantity here is the point at which you're indifferent for production purposes, okay, and therefore the quantities that you're going to produce are going to be above this point. What does that tell you about the nature of this curve in and of itself? What is another name you could give this curve? Yes, absolutely right. Well done. That is going to be your supply curve. But it is only going to be your supply curve above this point. Right? Because below that you don't make anything, you don't produce anything. There's still costs there for sure, but you can't afford to make anything. So the only supply is from here up. Well done. It usually takes students a whole lot longer. I think the next one is, yeah. Where does the marginal cost curve intersect with the other cost curves? Last thing we'll do today. Okay. Maybe. Yeah, okay. See what you've done. Very good, Amira. See if the others can pick up on it. Waiting on a couple more. There we go. Yes, good work, Zara. Still waiting on a couple. Okay. Well, that explains it. Yeah. All right, team. Okay, thank you very much. You've got about 5 minutes walk time to your next lesson, as we'd say in the land of my birth, He Kornera, which means goodbye for now. Now, tomorrow is Wednesday, or Woden's Day, or Odin's Day. Sorry? Mittwoch. So, as I said to you yesterday, right, Wednesday is the IB Taster Day for Year 11s. So what will happen is magically work will appear in the classroom for you to do. You are to do that work. You can't do it in here, I don't think, because I think I'm using this room. Hopefully I am. Because I will be explaining IB economics to the Year 11s. No, because it's last lesson. So yes, theoretically you could use this room because I think I'm going to be in the MPR. Alright? Otherwise, we shall see you, well, at some stage, probably tomorrow. See you. Thank you. Have a great day.